Hello, welcome to my channel. Before proceeding to study, please subscribe to my channel. Today, we will explore the fascinating world of basic mechanical engineering. We'll dive into key concepts like Introduction to lathe and drilling machines and their various operations. Slide 1. Introduction to lathe machine. Let's begin by understanding the lathe machine. A lathe is a fundamental machine tool that removes material from a rotating workpiece using a cutting tool. The workpiece is fixed to the chuck and rotated, while the tool moves in linear directions to cut. The main parts of a lathe include headstock, houses the motor and the spindle. Tailstock, supports the free end of long workpieces. Bed, the base of the lathe that supports all parts. Carriage, moves the tool along the bed. Tool post, holds the cutting tool securely. The working principle is based on rotating the job and moving the tool along required directions to achieve cutting. Some common operations include turning, reducing the diameter. Facing, creating flat surfaces. Threading, cutting threads like those on a bolt. Lathes are of many types, from manual engine lathes to computer-controlled (CNC) lathes. An important example is stainless steel shafts made via turning and facing. The lathe is often called the mother of all machine tools due to its versatility and ability to perform many base operations. Slide 2. Introduction to drilling machine. Now let's talk about drilling machines, also called drill presses. These are used to make round holes in materials like metal, plastic, or wood. Its main parts include base, foundation of the machine. Column, supports the head and work table. Spindle, rotates the drill bit. Drill head, holds the motor and spindle. Work table, supports the workpiece. The working principle is simple. The rotating drill bit presses into the material, gradually removing it to form a hole. Common operations are drilling, to make holes. Reaming, to finish holes. Tapping, to make internal threads. Countersinking, to prepare holes for flathead screws. Drilling machines come in different types like bench type, pillar type, or radial type. For example, using a twist drill to create holes in a steel plate. These machines are essential for mass production and fabrication, especially for assembly-based industries. Slide 3. Lathe machine operations. Let's go deeper into what a lathe can do. 1. Turning. This is the basic operation of reducing the outer diameter of a rotating workpiece. Think of reshaping a thick steel rod into a thinner one. 2. Facing. Cutting a flat surface at the end of a workpiece. 3. Parting, cut off, used to cut off a section of the job. 4. Knurling, creates patterned textures, diamond or straight lines, on handles or knobs to enhance grip. 5. Threading, used to make screw threads, such as on bolts or rods. 6. Drilling, yes, you can also perform drilling using a drill mounted in the tailstock. 7. Taper turning, producing a gradually reducing diameter. 8. Boring, enlarging an already drilled hole. 9. Example, a stepped shaft made by turning and facing is a good real-world use case. Each of these operations is fundamental for component manufacturing in mechanical workshops. Slide 4. Drilling machine operations. Let's understand the multi-purpose nature of drilling machines. 1. Drilling, creating a hole of a specific diameter. 2. Reaming, enlarges and smoothens an existing hole to precise dimensions. 3. Boring, like reaming but with greater material removal. 4. Counterboring, enlarging the top part of a hole to accommodate a bolt head. 5. Countersinking, tapering the mouth of a hole for a flathead screw. 6. Tapping, creating internal screw threads. 7. Spot facing, cleaning and smoothing a surface around a hole to ensure proper seating of bolts or nuts. 8. Example, a bolt needs to be inserted. First drill, then ream, then tap the hole. These operations make the drill press a powerful tool in assembling parts with fasteners. Slide 5. Differences, lathe vs drilling machine. Let's now understand how a lathe and a drilling machine differ in basic functions. In a lathe, the workpiece rotates while the tool moves to cut it. In a drilling machine, the tool rotates, and the workpiece stays fixed. A lathe is mainly used for operations like turning, facing, threading, and tapering. A drilling machine is mostly used to create holes using various tools like drills, reamers, and taps. Tool movement in lathe can be both horizontal and vertical. In drilling, the tool usually moves only vertically. Lathes are more versatile and suitable for shaping round parts. Drilling machines are faster and simpler for making accurate holes. Lathe setup is more complex, but offers higher precision. Drills are easy to use, especially in mass hole production tasks. Example: making a cylindrical shaft with threads is best done on a lathe. Drilling a bolt hole in a plate is best done on a drill press. This slide helps you decide which machine suits your job. Lathe for shaping, drill for holes. Slide 6. Advantages of lathe and drilling machines. Let's now understand what makes these machines so important in workshops. 1. High precision. Lathes can produce fine surface finishes and dimensions. Drills make accurate holes with proper setups. 2. Versatility, especially for lathes which can turn, drill, cut, and more. Drills can also be adapted with attachments. 3. Productivity, speed and ease of operation increase output, especially in repeated jobs. 4. Repeatability, CNC versions can produce exact replicas with minimal error. 5. Ease of use, manual drills are very simple. Lathes require basic training but are still learner-friendly. 6. Customization, cutting tools and fixtures can be changed for different applications. 7. Maintenance, regular lubrication and alignment checks keep them in good shape. 8. Cost-effective, manual versions of both machines are budget-friendly for small workshops or educational use. 9. Example, in making a steel bolt, the shank is turned on a lathe and the hole for a pin is drilled on a drilling machine. Together, these machines are the backbone of any mechanical production workshop.